All right, hello and welcome everybody to the 6th episode of Tech Life Skills with Tanmay. I hope everyone's staying safe. I hope everyone's keeping well. Thank you very much for joining today's live stream. And before we begin, there's something really exciting that I want to share with all of you, and that is that today it happens to be my sister's birthday. And so a huge happy birthday to her, and while we can't be there in person, we are actually getting a cake delivered to you right now, and I'm sure you're watching right now, so I hope you have a lot of fun. We miss you. And what a coincidence this is, that not only am I hosting this webinar today with our special guest Piotr, and we'll be hearing from Piotr in just a moment, that too on my sister's birthday, but it also happens to be my friend Abik's birthday, who also works on one of Piotr's teams. And so a huge happy birthday to my sister Tanvi and to Abik. Now, today's discussion is going to be really fascinating because we're going to be taking technologies from the past and technologies from the present, and we're going to be combining them to make a really futuristic experience. Specifically, we're going to be taking a look at how technologies like databases tie into the operationalization of machine learning technology in enterprises, and the kind of impact that that new technology has on the developers themselves. Now, I'm very excited to begin our discussion with our special guest. His name is Piotr Mierzejewski, the Executive Director of Db2 Development at IBM. Now, Piotr and I met a couple months back, around August 2019, back when I started working on a new project called Analyzer. And Analyzer is this really interesting project taking cutting-edge compiler technology and machine learning technology to enable developers to test their code in a better way than ever possible before. Now, that project is still under active development. In fact, we actually have an IBM Think session on the project, which I will link to down in the description of the video on YouTube in case you'd like to take a look at that. But without any further ado, I would love to welcome Piotr to the show. I'm very excited, very happy to have you on board. Thank you very much for joining today. And before we begin our discussion, would you like to quickly introduce yourself?
Thank you, Tommy. But before I do that, I just, happy birthday to your sister and a shout out to Abik. Didn't realize it was his birthday today. I hope you guys enjoying it the best way you can in this crazy world, right? I would also like to say thank you for everybody to find time to join. Wherever you are, good evening, good morning, good afternoon. I hope you're staying safe. And then I'm super excited to actually talk about this. This is a super interesting topic. It kind of maps to my career at IBM, where I spent machine learning, relational databases. The symbiotic relationship that exists, that is actually very not well defined and can be misunderstood. How those two technologies from so different eras, DBMS, something that we're very familiar with, was emerged about 40, 50 years ago, and AI and ML technology of the most recent decade, how they actually work together. How they are they even related? Do they need each other? Right. So very exciting topic, and excited to be here.
Thank you very much, Peter. Again, honored to have you on the show. Now, as you mentioned, the topics that we're talking about today really map to your career as a whole. And I feel like that's really interesting. And so I want to start off with a little bit of the past, right? So machine learning technology, let's go ahead and start off with that. And the reason I say that's the past is because that relates to your previous role before you were in this world of databases. So you were responsible for leading the teams that were working on DSX, or the data science experience, which is now better known as the Watson Studio suite of products. And I know that back when you were working on DSX and sort of what we call Watson Studio nowadays is what developers are more familiar with, essentially the goal, or at least one of the goals, is to enable developers to develop machine learning workflows for enterprise-grade applications. And so could you please walk us through sort of the why behind that project? What were the challenges that people were facing, the enterprises that developers were facing? How did DSX solve that? And maybe talk about like the future and sort of how Watson Studio and things are sort of evolving that notion or that idea.
Thank you, Tommy. That's an excellent question. And perhaps as I speak through it, I would like to start sharing my slides. I think this
Absolutely.
is
that would be great.
Right, so let me just start sharing. All right. So the general topic is about the databases and its symbiotic relationship with AI. However, before we get to that, let's start where it all began. Okay, and for that, I'm going to have to go back about 3-4 years ago when we actually started thinking about data science experience at the time, or what's in studio, and its need that to basically satisfy the needs of the enterprise's journey to AI. Okay? And with that in mind, what we very quickly realized is that many people think that AI and ML is just easy, right? It's easy and it's simplistic in a sense that we have explosion of open source algorithms. So there is frameworks from XGBoost, Scikit-learn, TensorFlow, Keras. Everything has been kind of given to the developers, and all they need to do is just, you know what? Yes, I'm expert in data science, expert in math. I kind of understand the use case. So with the given, a public data set, I can just create a model and have it ready in no time. If I was to challenge you to build a recommendation engine, based on some public data set, I'm pretty sure to 2-3 days from now, you could have something working. So essentially, that's a perception that has been created by the explosion of the ecosystem, by the fact that data science becomes one of the hottest disciplines in the market. And everybody understands that this is the key element to getting insight and knowledge and the business insight, essentially, from your data that you actually possess. However, this could not be farther from the truth. Since while individual data scientists can, like yourself, for example, can develop such model, it is a totally different thing when you start thinking about machine learning lifecycle and a whole ecosystem of actually personas and actually tools and processes that have to be considered to not only develop and basically the work on the machine learning model and develop it, but actually getting access to the data and actually deploying of it. When I talk about this is what I essentially call productionalizing ML, or creating machine learning and AI enterprise grade. Okay, and for that, I would like to say this is what I personally think the real world ML looks like. Now, obviously, the first stage, there's no ML without data. Okay, let's be very frank. Unless you have the data, all you have is some fancy algorithms that really don't provide no value. But in the same sense, without machine learning and AI, the insight you can gain from your data is super limited, right? So the first step when we look at this vicious circle of ML, and it's an iterative process that data scientists and enterprises have to actually repeat with every single use case. It is all about data preparation. It is all about data ingestion, exploration, and data cleansing. Now, I would ask you a question. Would you say that all the data scientists are experts in SQL or DBMS, in Hadoop, okay, perhaps some streaming, Kafka streaming sources? Because let's be serious here. Like, we're not only talking about the technology of the past, like relational database and known SQL interface, but we're talking about the evolution of data over the last decades, and evolution that took us from the mainframes, from relational databases, okay, and then took us to the Hadoop, to the data lakes, when we recognized the need for unstructured data, and then the volumes of the data increasing drastically, exponentially every year. And then finally evolving this to streaming sources. And let's not forget the latest hot topic, object stores, right?
Yes.
Storage solution. So we're talking through basically the last 5 decades, through the 4 distinct evolutions, how the data is stored and being accessed. Now, to complicate this even more, there's not only one relational database. Let's be clear, right? We're talking about, there's Oracle, there is SQL Server. Yes, there is DB2, there is MySQL. So you can think of the complexity, and then we're going to go into open source databases like Mongo, document stores, Greenplum, right? We're going to start talking about the memqueues, and we're going to start talking about Kafka. And then, yes, there's object store, and yes, there's Hadoop. So if you think about the permutation of matrix, that the data scientist would have to understand how to access this data, how to basically understand each dialect of those data stores, this becomes incredibly complex.
Wow.
And the data access, after doing a considerable amount of research, we understood that data scientists were great in understanding the model's features, understanding the algorithms, the maths, the statistics. They were not experts when actually trying to access the data where it resides. Okay? So one of the principles behind the Ep.6, and let me just be very, very clear, Ep.6 is not a tool. Jupyter Notebook is a tool. Okay? Jupyter Lab is a tool. You can say that Scikit-learn, and it's a framework kind of, it's libraries, so on and so forth. But the intent behind Ep.6, it was for it to be a platform.
Yes.
It was a platform not only for data scientists, but this was an enterprise ML platform intended for, in a first data prep stage, for the data engineers. okay? Intended when we move to the model development, as we move through this circle, basic model development where the feature engineering is actually happening, a training and testing and tuning of the models. And this is actually the sweet spot. The sweet spot for the data scientists. This is essentially what they are, trained to do, and they would really enjoy to do.
Yeah.
And I want to distinguish between train and enjoy, right? Everybody been trained to become a data engineer, but would they really enjoy it? Not really, right? So, and then finally, as we move to the final stage of the model deployment and management. And the Ep.6 as a platform was there to facilitate basically the whole life cycle of machine learning development for the various personas. As I indicated, the data engineers for the data preparation, the model development, data scientists for model development, and then finally the DevOps engineers, DevOps infrastructure engineers, who are there to basically create the deployments, the model deployments, the scoring endpoints, the REST APIs to expose them. The frameworks for actually managing the libraries and the packages that are basically built in within those models to ensure that those models are continuously updated, monitored, and they remain accurate. Mm-hmm. So that's as if this wasn't complex enough. I would like to add another layer of complexity, okay? And that is all this machine learning, and we're talking about some modern frameworks, right? Often models are wrapped up in containers with the explosion of Docker and a shift to Kubernetes and the stateless applications. You have to add that. So you have all these modern architectures, okay, that have to fit within existing IT architectures of the enterprises. And within enterprise, you will find 5 different data stores. You will find variety of hardware, any from x86, PowerSC, Linux, some of them like Ubuntu, others like Red Hat, right? Yeah. So now you're adding all these complexities. Then you're gonna have this dispersion of skills and processes that are unique to every single enterprise, okay? Then you're gonna hit your data and application silos. As let's be frank, the enterprises have evolved over the decade, and you will find legacy applications that, has been running there for like 20, 30 years. However, they were never built with hybrid cloud, with containerization, with the stateless applications in mind, nor they were built with to such in a seamless fashion. Finally, let's not forget compliance, regulations. Some of our listeners might have heard about GDPR. Definitely those in enterprises have, right? Those are critical aspects. So while Tanmay can whip up enterprise data scientists to actually get access to data, to create and train the model, and then finally deploy it in a production where that model is actually making real enterprise decisions. Mm-hmm. Real enterprise decisions. It's a totally two different world. So just to summarize in one sentence, the thinking behind the Ep.6 being as a platform is creating of an ecosystem that actually allows to move you through the various phases of a machine learning development, a machine learning lifecycle, and allows various personas to eliminate the data silos, to automate and optimize things, and allow them to concentrate on the areas of developing technology they're experts in.
So what I'm going to do quickly there, Peter, so thank you very much for sharing that. That's really fascinating to see. And I'm going to let you continue if you have something else to share, but there's something that I wanted to quickly add. And that is that what you mentioned there around the gap between going from developing a machine learning model to actually deploying it in an enterprise environment where it's production ready. Those are two very different things, right? So I could rip up a recommendation engine on the Movie Lens database in 30 seconds on my Mac with Terry Create, but then actually giving that over to Netflix and getting them to put it on their platform, that's a totally different thing. So I feel like a good sort of analogy for the everyday consumer to understand what that gap is like take a look at like iPhone Face ID. So if I were to open up Face ID on my iPhone, right, I just go ahead and open my phone and there we go, it's unlocked. But then let's just say we transition this over to an iPad Pro. Things get a lot more complex. You would think that it would just be you unlock the iPad. But what Apple had to do to make Face ID a relevant experience on the iPad is they had to actually make it so that they have other machine learning algorithms that are not only relevant for understanding whether or not it's the same person's face, but even understanding things like, hey, is your thumb covering the sensor? Are you holding the iPad too far away for the neural networks to be accurate? Have you flipped the iPad over in a way?
Let's go back to the math principles. Introducing new variable into the equation unknown just increases the equation complexity and the permutations of the various paths we have to follow. Yes, it is. And by the way, all those rules, all those regulations, when we look at about, they're fluctuating and they're unique to every single business. Imagine if we were, loan approval processes for individual customers. If someone makes a mistake, if machine learning algorithm makes a mistake when I'm improving a credit card application for individual, the backlash of that is, let's say, limited. Yes, you can always resend the offer, you can kind of fix it. If your machine learning algorithm, it makes a decision, for example, for the national bank, right? When it makes a policy decisions, or perhaps should I invest in something or de-invest, the consequences of their drastic. I can even take it farther. I did meet with actually European National Bank for European Union that actually controls not individuals by banks. And the questions I was presented is, how accurate is this? Because if you tell me to make a decision, I can shut down the bank that affects our whole country. We do have to understand that there's a huge, as you actually articulated yourself, it's a huge difference to actually accessing some movie DB and providing recommendations, and hey, this is the movie you should watch. Or versus machine learning models that will be making decisions that affect not only individuals, not only individual enterprises, but can affect the whole countries that it is. So huge difference, obviously, and it's tremendous. Hence, this need for enterprise-grade platforms that standardize on basically industry standard for each technology, from let's say REST APIs, machine learning algorithms, the package that are used, to the means how those are exposed, monitored. I don't want to get into basically the whole topics of lineage and topics of explainability of models, because that's actually beyond the scope of the initial conversation I thought we were going to have. Would like to move eventually to the role that RDBMS play in this world.
Yes,
so
absolutely.
Interesting questions, tons of topics to get into, as we only scratching the surface. However, if you don't mind, I don't want to run out of time without actually telling our audience to say, okay, well, how does this RDBMS connect and play the role in this world?
Totally. I would love to get into that now.
All right. In that case, let me move to something else. All right. So it is all about developers. Okay. Let the DBAs not be upset with me when I say that. But it is. And when I say developers, it's a broader, right? So, data scientist is developer, application developer is a developer, right? So I'm expanding this laws. But when I look at DevOps and the DBAs, they're also responsible for development and special features and part of the equation that makes this vicious called ML click, right? So when we look and we look at RDBMS, and on purpose here, I want to abstract this discussions while I am executive ML should look like or could look like, okay? So yes, it is about transformation of the business, okay? It is about embracement of open source. It is about adoption of industry standards. The times when the enterprises were fine with being locked into the specific vendor and as the use case that the vendor provides are all gone. There is not a single CEO out there that is not thinking how I can infuse open source AI and ML into my enterprise software stack and actually to optimize my business, how to modernize my business flows, and maybe discover new use cases, right? That also comes with that fact that you need to have all the data at your fingertips. And that becomes critical, right? Because we mentioned, okay, yes, RDBMS being the primary topic here, but let's not forget Hadoop. Let's not forget about object stores. And let's not forget something as simple as Excel. Mm-hmm. Tremendous amount of data that is owned by business analysts, it still favors Excel. And yes, they do their own thing. So how we look at holistically as all these heterogeneous data sources, they were born in different eras and are delivered in different fashions, at different speeds. Right? Think about it. Streaming applications can consume, for example, they can generate millions of events per second. That's your IoT world, right? When you dump stuff via ETLs into Hadoop data lakes, well, the speed of the delivery is not as essential because you're running deep analytics on it. When you look at the RDBMS, it varies, right? From OLTP applications that talk about 1,000 transactions per second to queries that can run, half a day to analyze petabytes of data, right? So now how do you create this virtual plane that will allow you to communicate with each other? And how your relational database is going to play its role within this world? What the access to it look like? What will be the single interface that can actually combine all this together? Now, last and not forget, there is need for agility. There is need for faster return on investments, right? No longer the projects are expected to last 2-3 years. The expectations from the enterprise are actually the project from inception to the delivery of some kind of MVP has shrunk from years to months and soon to be expected to weeks. With that, you need to be able to create and test, deploy in a seamless fashion that does represent the circle we talked about earlier. Okay? So now, how I would like to split this discussion into 2 pillars. Okay? Because when I think about relational databases and AI and ML, I like to think about it from 2 distinct pillars. First one is actually being powered by AI. Okay? And this being powered by AI, it means that those features kind of abstracted. It's something that is integrated deeply into the database engine itself. And that's where the AI ML is being leveraged to optimize the database performance or, for example, workload management. And the areas that I was basically kind of highlighting here, it's the 3 large pillars. Query optimizations, right? One of the most critical items. And if you're doing a time check for me right now, please give me a hint when we almost are time, because I need like 5 minutes later to wrap up.
We're good to go. We're good to go. You're sharing a lot of really insightful stuff. I would love to. I would love to hear more.
Okay, excellent. In that case, let's talk about query optimization. When it comes to relational databases, query optimizer is the heart of the whole database, right? It makes the decision. And by the way, the industry standards right now are cost-based optimizers. But it makes the decisions based on statistics that have been generated on the database, the data within the database, how to spread specific query, right? Unless our audience is basically, from a DBA or relational database background, they might think, the query, it's something simple. You write this kind of, I join 2 tables, I have the output, that's kind of a paradigm. In reality, the warehousing queries can join hundreds or even thousands of tables.
Wow.
They access billions or hundreds of billions of rows. I've seen queries that access trillions of rows of data, and they join hundreds of tables, and each of those tables can have up to 200 columns. How do you work with something? And a small mistake when you actually are estimating, let's say, cardinality, meaning how many rows will be returned from that table based on this kind of question, the query being a question, a mistake in such overestimating or underestimating can cause disastrous query access plans. So a query, to give you an example, that can run with the bad plan for about, half a day, let's say 12 hours, with a good plan can complete in 10 seconds.
Wow.
Exactly.
That is really interesting.
We have examples of that. This is the magnitude of difference that it makes in a query execution time that the correct plan is selected.
Yes.
With that in mind, we've infused relational database with machine learning models that in turn are used to provide statistical information based on the query predicates that have been used. So that's basically from the heart of the database, that's query optimizer, right? So we now train the machine learning models with the statistical data. And when the question comes to the database, it is machine learning models that basically respond is that, yes, this is the selectivity. Yes, these are the predicates you should use. And yes, this is the number of rows that has been returned. In our experiments, we found that they are about 10 to 20% more accurate than a cost-based optimizer. And in this kind of a world, when we're trying to be right 100% of the time, 10 to 20% more accuracy is actually critical. Okay, so that's from an individual query optimization perspective. But then let's get a step higher and say, well, the enterprises don't work with one query at a time. We're talking about the whole workload. So how do I manage various workloads of queries? Anything from a simple point query that is expected to return in sub-seconds to large analytics queries, right? That can actually take, rightfully so, an hour or even more to run. And then obviously would like to leverage your system to be able to run as many of those as efficiently as possible. And with that, we infused machine learning models to actually manage our workloads. And we use standard practice of continuous learning and feedback loops to actually augment the results. So when we actually get a workload, we try to make estimates, right? We look at the characteristics, we make estimates. This is how long it's going to take. Now, when we actually finish the executing of queries, we actually collect the actuals of the execution. Those are then in turn fed into machine learning model to augment the model and improve its accuracy for when the next time this kind of workload is encountered. And if last but not least, I don't want to dwell too much on the subject, but last but not least, is actually building out an infrastructure for hosting machine learning models inside the database engine. And a question to you, Tanmay, why do you think that actually hosting a machine learning model, okay, within the database engine would be a critical or very important capability for the RDBMS to be considered the AI database?
I feel like there would be two reasons to it, two that I could think of. First of all, security. The closer that you have your algorithms to your data, the less it's in transit, the more secure you can make your system. The easier it is for the end enterprise to actually ensure that things are, meeting regulation standards or whatever they need to do. But also at the same time, performance. If you've got terabytes or petabytes of data, instead of shifting it over from a database over to some other platform where you're running your machine learning, being able to do it within a single environment makes it faster at the same time.
Precisely, and you nailed it. Yes, security, data resiliency, and when talking about the security of the data, there's a few things that are actually considered there. First of all, data resiliency. So you might have a data that is stored, let's say, on Azure, right, in one availability zone. However, your data scientists in the distributed teams might be working not in US but in Europe, or let's say in Asia Pacific. Now, can your data actually leave this availability zone? Or are there any regulations that prevent this from happening? So while perhaps technically possible, yes, it would be, but when the data leaves special geospatial considerations, geographies, you can be actually breaking some compliance and regulation rules. So yes, 100% security, but security is actually a very composite topic. So yes, so data resiliency. Data access itself, like are you able to get, like are you allowed to have access to certain, let's say, columns, some certain properties of the tables, while you might have access to some columns that don't have any IP information, okay? There's others that could even never leave it, regardless if you're in the same availability zone or geography or not. Finally, auditing capabilities. How do you audit access of the data? Think of a complexity. Now, you actually extracted the data from relation database where you do have a strict policy rules and implemented audit capabilities to a laptop of the data scientist. Now, how you actually know, has he discarded of this data? Has it been properly? Yes. Who else used it? Has it been actually put on a USB? This is the type of questions you have to ask yourself. So that's actually various dimensions. When we talk about security, you have to think about those, right? Now, the second part, you mentioned the performance. And then you're 100% right again. Because what we've experienced, what we actually done is that when you work on, let's say, data samples, okay, initial explorative phase, when you're exploring your data and you're trying to kind of figure out the features, appropriate features, you're working, let's say, with 1,000, 100,000 rows. It's sufficient, right? It's kind of sufficient to give you an idea how the data is distributed, is it kind of valuable for my model or not. However, when you go to the paradigm of using 10 million rows, hundreds of million rows, and the only way to actually get this data out is actually through via JDBC or ODBC connectors, you're looking at 40 minutes to move via network the 100 million rows that you require to properly train your model.
Wow.
Okay, so exploration, yes, okay?
Yes.
But actual training on the large data sets, okay, when we're talking about hundreds of gigabytes of data, it becomes not only impractical, but actually impossible. So now, instead, yes, go ahead, please.
Quickly, one thing that I want to ask you there. So you mentioned, this is a little bit off topic, but I feel like we're in the same sort of vein. So sort of combining what you're mentioning right now, as well as what you were mentioning a little while ago about the query optimization, a question that I have is, I'm sure you've seen a couple of these demos. I feel like Allen AI is one of the companies that's, or organizations that's really working towards this demo. And they've got this thing that converts natural language data, so natural language queries to SQL queries. And personally, I feel like they're really good demos of natural language processing technology, but I feel like they're not that great when they're applied in a practical way because, I mean, as you mentioned, there can be hundreds of tables, there can be, hundreds of different columns being used, trillions of different rows. In a real enterprise, data becomes so complex that demos like this don't really scale, is kind of like the word that I would use. Do you feel like technology like this also has the capability to be sort of useful in an AI-powered database, or do you feel these sorts of technologies are better kept as demos? Or what do you think the role of that tech would be?
That actually is a great, excellent segue for me to switch the slide. Because while we're talking about RDBMS being powered by AI, The second pillar that I want to concentrate for is what does it mean for our DBMS to be built for AI?
Yeah.
And this is an excellent segue. So now we have NLP capabilities, right? Obviously, you're mentioning some kind of demos, and for a simple structural queries, for some fairly straightforward reporting, I see there is actually potential over there. And we have been at IBM investing in this kind of stuff in this space as well. So for example, you can ask a database a question as, pull their like the revenue numbers for the last 3 quarters, organize them by region, okay? Or for example, organize them by product. And I believe that this type of fairly simplistic, believe it or not, queries can be actually driven via a conversational NLP to SQL translator, right? And allow you, perhaps you would not, you would not create a sentence that would describe the result of the report you want, because that creation of that kind of SQL would become very complex. However, you could have it kind of conversational SQL paradigm when you say, pull in the latest sales for that quarter for North America, okay? That gives you a result of the query. Now, at that point, you would actually follow up with additional questions, breaking down by region or by state. Break it down by specific product, right? So in a sense that you start the conversation, you still remain, your SQL statements that are being generated from an NLP are still remain fairly straightforward, and they allow you this capability to slice and dice and drill to the data. Right. So in that space, I believe that yes, there is potential for this. Right. And then it can redefine like this NLP to SQL conversion. It can redefine not only application development perspective, right, for data scientists, but it can actually redefine how DBAs work out with points to say, hey, how is my hardware performing? Hey, how many queries, right? How many queries? Oh, Siri, how many queries execute in my database today, right? So It changes. It changes this whole thing because yes, we have a well-defined abilities to understand the human language to the certain context and translating, let's say, auto-generated SQL. Or, for example, for the database that would be built for AI, the RDBMS providing REST APIs that can actually, once that SQL is generated, create the static and dynamic SQL statements, then return the data in JSON format. Because that's what modern applications expect and understand. Why would I need to go additional layers of complexity via JDBC and try to translate, SQL to this and then form a JSON object, feed it into my application? Well, you wouldn't. The expectation is that with the frameworks like, let's say, React and Angular, each widget is capable of making a REST call and, asynchronous REST call that is decoupled from the other parts of the application. And it allows for much more seamless and driven and unique experience to be able to retrieve the data that is specific to the query and the widget that you're interacting with, right? So I don't know if this answers your questions, but yes, to a degree.
It definitely has. And actually, to sort of elaborate upon that even more, I mean, I feel like even just generically what you touched upon is that developers are expecting more and more of infrastructure code to be done for them, and in a way that's really good. Because when infrastructure is common and when infrastructure is built across enterprises, it generally becomes a lot better because then we're not reinventing the wheel every time, right? So for example, Kubernetes is a great example of that. We've got all sorts of examples of this. And I mean, even in terms of infrastructure, it's not even just Kubernetes. Even more specific examples like Swift UI. Why do people love Swift UI when compared to storyboards and UIKit and AppKit? It's because now you're not manually sitting there and defining where your labels and your buttons and your objects go and then how auto layout's going to constrain. You just tell Swift UI, this is what I want my view to look like, handle it. And Swift handles it, right, on any device, on any platform, whatever. And so it's a lot more convenient. And same thing with TensorFlow versus PyTorch. Why do people switch from TensorFlow to PyTorch? Because they expect infrastructure to be dealt for them. They expect that their GPUs are synchronized for them. They expect that they don't need to deal with TF records. They expect these things. And again, it's good because when it's centralized, when it's open source, when there's a large community working on it for everybody, we end up getting a better result. Linux kernel, again, perfect example. And that actually brings me to another point around standardization and infrastructure abstraction. And that is actually something that I see on your slide there, Big SQL.
Right?
Now,
Okay.
we both work at the Canada Software Lab, IBM Canada Software Lab in Markham, and there are a couple of hallways at the lab where I would pass by, and I don't remember what exactly it looks like, but besides some sort of room, there's a poster that says something along the lines of Big SQL is the big data world's best kept secret. And that fascinates me because there's no machine learning without data, and so what exactly is that poster talking about? What is Big SQL? How does that help data scientists? What sort of impact does that have?
Excellent question. And you know what? While we skip the points in between, we can come back to that if necessary. But this is actually an excellent question, and it goes back to our initial when we started this conversation. We talked about evolution of relational data stores, and essentially relational evolution of the data stores, right? Going from the mainframes to our DBMS to Hadoop to object stores. Let's not forget Excel. Let's not forget about streaming versus ETLs and batch. Let's not forget about structured and unstructured. Now, how in a world where data scientists is expected to learn all those languages? How is expected to learn how to access those data stores? How do I actually take the data from there without removing it, since we understand that it's critical, the security around that is very critical. Now, how do I have create this plane of glass that allows me a single query interface to interact with all of those? And that's precisely what the Big SQL is. Big SQL has been developed from federation technology. Federation, as per its name, implies that we're trying to federate the data from heterogeneous data stores via single query interface. And that's a technology that's been around for about, let's say, 20 years. It has been evolving, and within Big SQL, it has entered its, I would say, second stage in evolution, right? When outside of the relational data stores and, for example, Hadoop, we started to adding data sources like Excel, like Kafka streams, okay? Like document store and open source databases, right? And with that, we're still providing a single query interface where application developer or data scientist can work on a standard SQL interface in a sense, a standard SQL standard, and it can access all those various relational and other stores, while the Big SQL itself decomposes the query so it accesses each specific data store with its dialects. It takes care of the data access, of the push down of the specific predicates, let's say, aggregation of those results, and presenting them in a unified view. Now, this third stage of the evolution of the Big SQL technology is something that is actually very popular right now and spoken about the Gartner and the various enterprises. It's actually data visualization. So what you're actually doing, you're creating within the Big SQL, Federation Big SQL data visualization, you're creating this abstraction, this virtualized view, let's say, that represents those heterogeneous data stores and provides you with a single point of interaction. Now, in turn, once you define it, obviously you can offload the access and setting up the access to your data engineers, and then your whole experience changes when you actually start working with the single virtualized data source that satisfies your needs of your specific machine learning model or project.
Mm-hmm. So thank you for sharing about Big SQL, and I know I kind of had you skip through a couple of those points, so I would love to hear what else you have to say about how databases are built for AI.
Okay, fair enough. So yes, the Big SQL, so the data access, and it is of my opinion, that it is the RDBMS responsibility to provide this virtualized layer to be able to coordinate and talk with others. However, we're not only a step of that. You mentioned that developers have expectations, right? Yes, they like one of frameworks like Kubernetes and Swift and so on and so forth. They also have expectations that the language of their choice is supported by relational database. So no longer CLI or Java JDBC is sufficient, or a C++ or C connector, right? But now we have to work and be able to interact the choice. So if they want to run Node, they want to run Node. If they want to run Python, they want to run Python, Scala, R, Go, you name it. And with the explosion of the various languages and frameworks, that list just keeps growing. It is essential for the RDBMS to support pretty much every single language that's out there. Then they're developing one. Otherwise, if you don't, developers are lazy, in a sense. or they're not that lazy, but once they learn something and once they master the language, they expect that the databases in the future will be able to talk that dialect. Mm-hmm. So as we're actually moving now from a bottom up, so yes, so definitely being able to talk in the modern standards like REST, definitely be able to talk with all modern languages, open source, so on and so forth. Yes, being able to provide this virtualized view on top of it, but also is like, how do you simplify my life? So we've talked about the machine learning lifecycle, right? Okay, and we say that, oh yeah, so model development is just, the second stage of it, right? Okay, so if big SQL data virtualization is gonna cover the first data access for me, okay? When the tools that are built in, I can actually use to create the model itself, how easy are you gonna make deployment of that model for me? Okay, so that's a part, the last part. And here, I would like to say that the support for Python and R user-defined functions, okay, so UDFs for not RDBMS folks, user-defined function. It's essentially RDBMS needs to provide the Python or R runtime for me to be able to deploy my assets. So if I create a PMML model, or I have an MLlib, or I have a pickle, or even Spark ML model, I need to be able to deploy it on the edge of the engine. Okay, so my job is done. You handle this for me. All right. So that's actually kind of completes the circle of ML and provides the infrastructure for my models that I've deployed to be deployed by the side of the engine in this kind of user-defined function environment. So I can actually do it for inferencing and about scoring, or for training if I really want to. Right. So that actually then it's becoming our DBMS responsibility to simplify this whole life cycle of the machine learning model development and provide the data scientists enterprise with the means to actually deploy the model on the edge of the database, okay, and do the all scoring interface inferencing and training without actual movement of the data. And that gives us, as you pointed out, security and performance benefits. Additionally, as one of the last points when I want to concentrate on here is just, for example, adding, I was trying to remove all the DB2 references, but here we got DB2 graph. So sorry, I wasn't meaning, I tried to extrapolate the conversation for generic RDBMS.
No, it's fine. We want to talk about these cutting edge implementations too, so definitely do share.
So another thing that RDBMS is required to support, relational data, yes. Years ago was XML, then we've had JSON, native JSON support, right? But now the graph technology has been, getting much more traction, as it is one of the best technologies to discover hidden insights. This dispersed relationships between your data, when a tabular format are being lost, while when you look at the graph with property paths which you can traverse to find the hidden relationships, it's just a new means of data exploration and gaining the business insight. So to summarize it is standardized access via REST APIs, okay? New emerging technologies, everything from the JSON to archaic XML, which still lots of enterprises use, don't get me wrong,
yes,
to new technologies like linked data and graph technologies with, let's say, Trinklepop, Gremlin language and property paths, right? To the modern languages drivers the developers expect. And finally, the virtualized view, single point of glass, like a single pane of glass that allows you to work with every single data source of your choice. So that I would say is that those characteristics, and by the means, this is not exhaustive list, would make the database RDBMS built for AI.
It's really interesting to see databases that are built for AI, and I mean, we talked about big SQL, but really quickly, before we continue, and before I let you continue and talk more about this world of what it means to have databases for AI and also other new technologies, a quick question that we have from someone on YouTube, and I feel like this is very relevant to our discussion right now. Why not use GraphQL instead of big SQL?
GraphQL. Okay, so big SQL. Okay, so first of all, big SQL doesn't allow you to work with the graph structured data. So this is actually DB2 Graph, is slightly different technology that we developed with IBM Alma and Research. The great thing that comes out of the DB2 Graph in this particular situation, it is actually very similar to earlier statement we made about pulling the data out for the analysis. If I was to look at the Neo4j, the current industry standard, or Jonas Graph, it still requires your data to be translated in graph format and basically extracted from the relational database and stored in appropriate format for graph consumption. Now, what we have done here, we actually created a Gremlin interface, so the data, just like in case of the Python UDF and in database machine learning, does never leave the database. Instead, the Gremlin SQL, the Gremlin language is being translated into the SQL under the hood. So you're actually running the Gremlin queries on the data that resides within the database. And only results of your queries are being displayed and translated to the graph format in your UI of choice.
Interesting.
So very similar motivation, right? As we've had with our in-database, creating machine learning pipelines with an engine, or supporting the Python UDFs or RUDFs that allow you to actually have the binary of the model deployed on a database engine. It is all about the performance. It is all about security and governance of your data, right?
Thank you for sharing, and yeah, absolutely. If you have any more questions about that, feel free to ask on YouTube, on any of the other social media platforms. We'll be getting to a dedicated Q&A session towards the end of today. But now I have another thing that I want to talk about, and I know this is something that you've been working on quite a bit. And that is, we've talked about machine learning, we've talked about AI, but now I want to talk about infrastructure. So we already touched a little bit upon Kubernetes, and we know that we're all in the Kubernetes era now. You know, developers expect infrastructure to be managed for them, and Kubernetes enables us to write infrastructure as code. Really an innovative concept. So could you expand a little bit more about how these databases that we traditionally see as these, large monolithic, applications of the past are now transforming to have those same advantages and what you just mentioned around RDBMS systems in this sort of AI era, but now for Kubernetes as well in these sorts of distributed systems?
Excellent segue to my last slide.
Oh,
and for our listeners that are already tired of listening to me talk, I promise this is the last slide. So let's be very fair. Everybody heard about Docker, right? Okay, so containers. Let's even abstract it farther, right? While I want to concentrate on Kubernetes here, which is becoming de facto the container orchestration technology of choice, it is all started with the container E. We're talking about the Docker. Docker obviously still holds tremendous value. I mean, there's a tremendous share of the market. However, when we talk about containers, and the principle behind containers was actually stateless applications. Let's just say our DBMS are not stateless. Those are stateful applications that have been designed and created with a mind that they have a full control of the server's resources. They start using C groups, kernel parameters. They're able to just squeeze out as much performance as you want. However, like the world of having dedicated hardware, dedicated for your RDBMS, is shifting as well, especially when we look at the developer personas. Hardware utilization is critical. It's spinning up to 24 core, 128 GB of RAM, VM on Amazon can get pretty pricey.
Yeah.
So what we're looking at is how we actually transition from this monolithic, as you indicated, legacy applications, and how we actually, evolve them to actually work well in the world of containers, in the world of kind of stateless applications that the Kubernetes and containers have been designed for. And with that, we are at IBM. We came up, in DB2 organization, we came up with something DB2U. It is actually DB2 engine has been broken up into various components. Because when we think about relation database, you're looking at the press console, you're looking at outputs, you're looking at the various tools, you're looking at the engine itself. You're looking for kind of auxiliary containers that actually facilitate HADR setup and disaster recovery scenarios, right? So in our next generations of containers, we've created something which is precisely it. Microservice container architecture that decompose this monolithic application, which was our DBMS, into smaller components, and certified it on OpenShift, build it out with the universal base image from Red Hat that has been very strict when it comes to security needs for what privileges can be basically used on a hardware when it's running. We've optimized it for the OpenShift with, let's say, with SC Linux and C groups, and ability to create custom context, security context with OpenShift, right? And we've basically integrated and started reusing the technology that Red Hat itself is driving. So with CoreOS and a Red Hat OpenShift 4.3, the Red Hat is moving, OpenShift is actually moving towards concept of operators. And what operators are is essentially structures that allow you to manage full life cycle and the various aspects of application lifetime, right? So what I'm actually highlighting here is something very straightforward. So the first phase one of the operators would be a basic installation, right? How do I automate through some repetitive process installation of my applications? And the goal here is that this is abstracted to the sense that once you have Kubernetes cluster, once you have your storage classes defined, okay, I'm able to use this operator to just deploy instances of the database at will. And not only database, because the same principles are being used for different applications. Would it be UI or kind of services, you name it, right? So it is the standardization of deployment or installation of the experience across various types of applications by actually embracing this type of technology. Before I go to the next phases of operators, what is actually important to highlight here, that using OpenShift, using the operators, it gives you true hybrid experience, as the means of how you deploy your applications are essentially the same, regardless if you go to Google Cloud, regardless if you go to Azure, if you go to AWS, or if you intend to actually deploy them, set up OpenShift on-prem on some bare metals for a great performance, and decide to deploy it in your, behind your firewall within your enterprise. So that's a huge game changer. It also changes the whole deployment and this kind of return of investment. What you expect, it changes it from kind of days to something that is happening within minutes. So not only agility, not only true hybrid cloud experience, but also standardization, how I interact with all my applications. Mm-hmm. And that's, by the way, while not directly related to AI and ML, but it's also essential property of the new modern age relational database, right? Yes. And that goes beyond just a simple installation. We need to, when we look at the phase two of operators, we're talking about the upgrades, right? The expectations are now that the application is like 5 nines, right? I don't know if everybody heard about 5 nines, but what it actually represents is the application is up 99.999% of the year, let's say, which in reality means that you're gonna have about 30 minutes downtime in a year.
Wow.
Okay, that's actually something, and those are precisely the kind of expectations where enterprises right now are looking at, right? So they want 5 nines. They want to be able to deploy it in minutes. They want to be able to upgrade this kind of from one version to the next, also seamlessly. We're talking about blue-green updates, right? And by the way, we'd like to standardize that I can actually use the same methodology for upgrading, installing my different applications, right? So now, finally, with the further phases of operators, we get into full life cycle management. So backup, restores, any kind of failure recovery, final matrix, logging, monitoring. So as you can see, this builds out the common infrastructure, which you were referring to earlier, right? With common infrastructure for not only our DBMS, but different type of applications, more of a stateless applications, to be managed and hosted on this one, scalable, resilient, hybrid cloud experience. Now, while this might have been native for the applications born in the era of the cloud, it was not for our DBMS. Yes. However, I'm happy and proud to say that, if I can share some links, we are already getting on phase 3. Wow. So from DB2 perspective, it is a next generation RDBMS that has been born in the era of Kubernetes, era of containers, and the era of hybrid clouds.
I have to say that it's genuinely incredible that we can take something as large and as complex as a system like DB2, or really any RDBMS at that scale, and containerize it in the first place, and then get it to work with all these new sort of infrastructure handling techniques. It's pretty amazing. I mean, I've literally I've seen the work that the people on the teams are actually doing to make this sort of phased approach possible, and it's really incredible the work that they're doing to make this transition from monolithic, expensive, the sorts of databases that you can't, like, for example, what you mentioned around upgrading easily, things like this, and being able to transition that to this sort of new Kubernetes era. It's again, once again, really incredible stuff. So actually around that, what I wanted to ask was sort of about the future of databases like this, right? So We've seen what databases are like in the past, right? We know that developers weren't particularly excited by them, and we also know now that in a way, the way that different databases are generally, the way that different products compete with each other at this point has transitioned from being just like better in individual features or functionality to having to be better at the infrastructure. So, for example, TensorFlow versus PyTorch, technically TensorFlow will give you better performance, but still people will sometimes choose PyTorch because it's just so much easier to work with. And so people now are choosing products based off of their infrastructure, not necessarily based off of their functionality, just because people are that boundary between different functionality starting to fuzz. And same thing with DB2, same thing with TensorFlow, same thing with all this other software that we have out there. And so keeping that in mind, and keeping in mind that there's so much sort of to expand into the future with this technology, what other technologies apart from machine learning or big data do you think are going to be molding the way that databases work in the future?
Oh boy, that's a loaded question.
It is.
Obviously, over the next years, the expectations will just get higher. Right, so I believe that the full adoption of, let's say, five phases of operators, the abstraction and the unification of database management, as it portrays, and then actually unification with stateless application development. More of that ability to auto scale without any kind of any interactions from DBAs and application developers. I would say simplification of the whole, as you call it, infrastructure, right? Ability to scale at will, all about to have a better ROIs, all about simplicity, integration, better integration actually with machine learning frameworks that are out there, okay? Basically creating this, automated flows that actually kind of fit in this machine learning lifecycle. Explore, integration of additional capabilities, like a single, I would say, another phase for data visualization, right? So we will, okay, I'm actually jumping around here because as you ask this, I'm starting to think about different areas. And the more I see, the more I'm missing. So how about that? Let me step back and let me go from, let's start with infrastructure and let's move back. So definitely adoption of the all operator phases. Okay, so simplification to access, deployment, management, and basically full automation around it. And also
really quickly, maybe what you could do is stop sharing your screen. Oh, I can just do that for you. There we go.
Never mind. There we go. Yep. Okay, yeah.
Go ahead.
So everything from bottom-up infrastructure to create this uniform experience for managing it just as other applications, right? Yes, it's the hardest with the RDBMS. And let me be frank, while we have achieved amazing things with DB2U, we've started the journey in DB2 and containerization over 4 years ago. Okay, so this is our next generation container, and what we've done is based on the knowledge that we've absorbed, the things we learned over the previous 3 years, right? So yes, simplification of infrastructure, adoption of operators, that's going to be essential for any RDBMS that wants to survive in the future. Okay, complete infusion with machine learning frameworks. Okay, and this ability to host, serve, interact with machine learning models, technologies, not only the models themselves, but even with, let's say frameworks themselves and platforms, right? Then continue creating this ecosystem for the developers via simplifying how they actually interact with the database and how they discover and cleanse and work with the data within it. Even more so, if such RDBMS can provide this uniform view that the interaction with different data stores will be abstracted for them. Okay, expansion to add additional paradigms like graph that we've talked about over here. Obviously, something that you brought up, conversational RDBMS. How about that? Okay, so definitely conversational RDBMS that it does infuse NLP and NLP to text, NLP to SQL, right? When we can actually start having a conversation with the data that's out there, right? So I think that's that's a broad mission. That's a vision for another 5 to 10 years. But I truly believe that's where we can experiment. The expectations are that customarily, I don't know if you heard about the HTOP technology, is when actually customers have expectations right now that your transactional system and your warehousing system should have a single interface, right? It's RDBMS responsibility to decide, do I go to the row store, do I go to column, how I break this down. It's just, so simplification across the stack.
Interesting to hear. So yeah, that's the future of databases, and there is another question that I want to get to. In fact, now would actually be a great time to transition into a live Q&A with the audience. We're getting in some really interesting questions. One question that I... Sorry?
They haven't all left yet?
No, not yet, not yet. They're really interested to hear what you have to say. So one of the questions that I see over here is hyperautomation, which is the combination of AI, machine learning, etc., with automation, is very quickly becoming a major focus for enterprise. Do you think there's an opportunity to combine hyperautomation with AI-infused databases?
Okay, you're going to have to help me here, because when I think about hyperautomation, I'm not familiar with exactly the term, but I've read about kubeflows. Kubeflows as a means of actually automating deployment and actually deploying the flows themselves, the applications, into various heterogeneous,
I have a feeling by how hyperautomation, they don't mean like the automation of the deployment of the databases, but rather automation of people's jobs and tasks.
Oh, okay, fair enough. That's all right. So I've heard questions, let's say, adding ML optimizer and fusing our DBMS with machine learning, will it eliminate the roles of DBAs?
Interesting.
And you know what? By no means, no. I don't believe so. There's still so many intricacies within the engine itself. Anything from schema design. We have to understand in relational database, everything is very well structured. That, so every application has expectations as to how the data would be laid out, right? Thanks to that, and it is extra effort. It is an extra effort defining those functions, procedures that allow you to better access this data, right? Defining those, what we call them, virtualized views, essentially, right? Structuring, architecting, essentially laying out the schemas for like data marts are super complex when you go into the star schemas and stuff, right? That requires tremendous amount of work. Now, it would be great, and the final drive behind this automating of a certain task is to follow out to DBAs to concentrate on schema design, on actual database design, versus managing the users, versus managing all this kind of tasks that are so needed, like upgrades. They would have to schedule, I need 2 days to manage my upgrade, right? Let's remove all that. Let them decide. Let them continue to design better and architect better structures of the database itself, inside the engine, the schemas, and everything else, right? Same way as we intend to actually simplify the lives of the data scientists and abstract the data access, abstract the deployment, and let them concentrate on something that they really do. So no, I don't believe that infusing ML, AI into database, it's like, as I mentioned, to operators and other different technologies, not just the AI itself, right? It will allow DBAs, right, to actually concentrate on a higher value proposition. Items, right? Like database designs, schemas designs, and this kind of optimization. Just like the data scientists are not meant to, interact with data cleansings and stuff like that, RDBMS, or actually meant to write REST API endpoints for their models when they're in deployment production.
I feel like a great way to put it, and I mean, you've worded it pretty exceptionally, and I feel like I was having a webinar with somebody else the other day. Unfortunately, I'm forgetting who it was with. If I do remember that, I will let you know. But during the webinar, the guest mentioned something along the lines of, with machine learning and artificial intelligence technology, we end up making ourselves more human than we were before. And the reason I really love that quote is because even in this scenario, it holds up just the same. We're applying machine learning within database technology, but at the same time, the DBAs, what's happening is the DBAs are becoming more human because they're working on the tasks that require that creativity. How's the data laid out for my application? How am I, in an abstracted way, how am I dealing with that data? Oh yes, I remember, the webinar was at Dr. Shafi Ahmed from London. We were talking about, AI plus surgeons, how does that mix? And he was like, with AI, surgeons become more human, they're doing tasks that require human skills. And within the database world, it's just the same. That quote is so widely applicable. So now another question that we have, this one's from Tina. And what I'm going to do is I'm going to quickly ask the question, and then I'm going to go ahead and give my thoughts on it. And I want you to tell me, Peter, if I'm thinking on the right lines. So the question is, does DB2 have machine learning capabilities built into its RDBMS functionality? Or is its strength in helping those who use machine learning in their applications, or both ways? My opinion on that is both ways, because I mean, as you mentioned, we're using machine learning in the back end for query optimization and actually handling the queries and enabling like an AI-driven database. But at the same time, it's helpful in the sense that DB2 is built in a way that it's easy for machine learning developers. That's what I got from the slides that you shared. Is that right?
That is actually precisely correct. I would actually add slightly different flavor here. Because
Okay.
yes, so being powered by AI is this when we talked about workload manager, right? Workload manager, let's say ML optimizer, so on and so forth. But I don't believe this is a part of that question. And even in the second part of the answer is like, okay, so we support easy means of, let's say, infrastructure for machine learning models, or this Python UDFs, RUDFs, to deploy my assets, my model by the edge of the engine, so we get this performance and security. However, there is another thing that I haven't really highlighted during our discussion is that we have implemented linear regression, classification algorithms, k-means clustering. We have all those algorithms actually created and wrapped into stored procedures inside the DB2. Mm-hmm. So those algorithms have been structured and written in a C language, so super performant, already inside the engine, and it allows you to create the full pipeline, full ML lifecycle pipeline, and using those stored procedures in DB2, okay? So you can actually fully train, deploy, and do every single of those, from ML lifecycle, all those stages. You can actually do feature engineering with procedures that are built inside the DB2. So I would say that's why the three pillars, right? I wanted to distinguish, move away from this being powered by AI, because I felt maybe the question from Tina was more about, okay, how easy you're gonna make it for me, right? Yeah, I still use my Jupyter Notebook. And by the way, yes, for anything that I'm describing, use your Jupyter Notebook. Use our studio if you want, right? Right, but then yes, call those internal C procedures in DB2 that will allow you to do feature engineering, that will allow you to cleanse it, that will allow you to do training, right? And then yes, you will not moving the data out. And I know I don't want to speak too high about it. We've done some performance analysis and those things are working great. There will be quite a lot of, you know what, I'm going to be a little opportunistic here. At the end of June, we're releasing something called DB2 Nebula. Okay, it's this next generation AI and developer friendly DB2. Okay, so there will be, there's the community editions. Everybody's happy, just take it, have fun with it. It's free. Okay, you'll be able to put it on Minishift or Minikube. Just have fun with it and try to play. Look at integration via REST API. Create your model, deploy on the side of the engine. Right, see the difference when you don't have to move this data out, right? Look at this ecosystem that we've created to actually win back developers. And I'm being very actually honest right now, and I'm going to be transparent. We need to win back developers because perhaps DB2 from a marketing perspective has been forgotten. It's a great enterprise database, but I don't think we've done enough to showcasing the tremendous things that we're doing for the developer community, right?
I agree. And in a way, I feel like we could kind of relate it to the situation that the Power architecture is in terms of, it does help a lot with sort of new technologies, but when a lot of enterprises are thinking about what are we going to be putting in our data centers, they usually think, hey, x86 is the industry standard. We're going to go x86, whereas they don't really see that, hey, you're missing this entire world of IBM Power CPUs that have this like super high, sort of built-in support for accelerators and all these things. The same thing with DB2. We got to make sure that developers know that there's this amazing solution out there that is developer friendly, that has the infrastructure handled for them, and is something that is both powered by AI, enables you to develop with AI, and has that AI sort of functionality and training built into it, those three pillars that you were mentioning. Now we do have another question. This is from Parag, and this is a very loaded question, and I want to see what thoughts you have on this. Any thoughts on FaunaDB and how it leverages the advantage of the Calvin algorithm for a distributed 100% ACID compliant transactional NoSQL database?
You know what? I'm going to claim the fifth here. I will not incriminate myself with a lack of knowledge about FaunaDB. Unfortunately, you know what? This question is way above my head right now. I will explain. I'm a just executive director. I have a fair amount of knowledge, but you know what? There's certain areas that I would need the help from my architects from. So, however, we can take this, Tammy, we can take it as a follow-up question.
Yeah.
I can definitely have one of my chief architects in DB2 and our distinguished engineers take a peek at it. And perhaps you can provide the kind of response in some in the social media essentially.
Definitely. So What I'm going to do, Parag, is if you could please go ahead and put your question in the comments of the YouTube video, that would be great, because that way Peter and I will go over to one of the folks within IBM that would actually know more about this stuff and go ahead and get back to you. But if by any chance you're not watching at the moment and you don't put it in the comments, I'll put your comment in the questions and tag you, and then we'll reply to that. But yeah, that's thanks for asking that question. I mean, now you've actually piqued my curiosity. I want to learn about this now as well. So another question we've got. So we talked about CPU architectures. We talked about x86. We talked about power. Power is RISC. RISC has all sorts of advantages. And now a question is about ARM. What do you think about different CPU architectures in relation to databases? Do you think ARM is the future in general? And what about for databases in specific?
Oh boy. Another level
Actually,
stuff. Okay.
wait, just a moment.
Yeah.
A quick question, actually. Does DB2 run on ARM right now?
And I'm gonna admit that I don't remember what this acronym is. I've heard it before.
ARM, it's the CPU architecture that's like that runs on like your phones and like the iPads and tablets. It's like a low power RISC architecture.
Okay. At this point, I'm gonna say it does not.
Okay.
We're looking at slimming down the engine. Let's be very transparent. We're talking about the 30 million line of code. We run on a variety, basically of architectures. So x86, obviously, we run on Power, we run on Linux, we run on Windows. We run on something, AIX. So tons of architectures that we do run on, and we perform in excellent fashion. However, it is enterprise. DB2 until this point in time, when we started working in the DB2U, was fairly heavy. Okay, and I'm gonna be very transparent about that. But with our basically pursuit of containerization and having this, as much as possible as cloud native architecture as possible, we are slimming down our engine. So I would envision that in the near future, we will have a slimmed down version of DB2, just a pure OLTP type of engine. And by the way, let's be frank, we're not going to be running deep analytics on your cell phone. This is not going to happen, right? So we see, unfortunately, at this point, DB2 engine provides all those various capabilities that I indicated. So the row store, the warehousing, the operational warehouse, all this is embedded intertwined in a single engine. We call it common SQL engine. This has its benefits, as you can actually use it for anything you really want. However, when you want to put it on the mobile devices, this does present a challenge. So we are in the process of slimming down the engine to the point that we can actually deploy it on edge. Essentially, we're looking at DB2 for the edge devices, right? For edge use cases.
Fascinating. I feel like also to extend upon your answer already in terms of edge, that's great. But also another thing that I wanted to mention is that people in different companies are really working towards high performance ARM chips as well, because the ARM architecture has inherently some advantages over x86. So with x86, you've got such a complex instruction set that a lot of the CPU, a lot of the silicon is just going to handling that complex instruction set, which in a way is inefficient. Whereas RISC architectures like Power and ARM, they can spend a lot more silicon with actually executing instructions instead of understanding the instructions. And so kind of like how Power is high performance RISC, people are really working towards high performance ARM as well. Apple, for example, is rumored to be announcing their new ARM Max soon. Hopefully that comes out soon. Who knows? Maybe they make a transition away from Intel. AWS provides ARM-powered servers. Microsoft has their new Surface Pro X. There's all sorts of different laptops and high-performance systems that are powered by ARM now, and people are working towards that actively as well. And so it'll be interesting to see that after DB2 developers are done slimming down that engine and getting it to a state where it's workable on even more architectures than today. And even today, it's incredibly portable, right? There's all sorts of platforms, as you mentioned, that DB2 runs on. I can't wait to see how it runs on ARM. So that's something for the future, but it's definitely something that I'm sure D2
something definitely I'm going to pull you in. As soon as we're done with the analyzer project, let's analyze this one. Right? Okay.
That will be fun. We'll talk about that on Slack. But so another question that I have, actually, sort of expanding upon the ARM question, although it's a different field, FPGAs. So FPGAs are fun. They're really quite incredible machines to be able to work with. My question for you is, does DB2 use FPGAs for things like optimization or to help it with performance? And also, does it make sense to use machines like FPGAs as accelerators for databases?
So definitely makes sense. DB2 doesn't play in that thing, but within our portfolio, We do have Netezza performance server as a private cloud for data, which does use FPGA acceleration. So, by the way, although Netezza source code was always built to, be able to leverage those. With DB2, we do various different acceleration techniques. We do optimize for basically input power, so on and so forth. We have quite a lot of low-level improvements actually done on the compiler level and everything else to actually leverage these hardware accelerators, not the FPGA by itself. However, we do have within our hybrid data management portfolio, which encompasses the DB2 family of product, as well as our Netezza analytics warehousing engine. We do leverage for that.
Interesting. Now, I actually have a question from another one of the folks that works on your teams, Omer Kamal.
Sorry. Okay, I'm going to have a conversation with them. They can ask me questions personally, not right here. I mean, come on.
Well, it's nice. Now everybody gets to learn. So, so the question is, so we talked about those 3 pillars of the AI-powered database, and one of them is that there are features built into the database that make it more convenient for data scientists or machine learning engineers to be able to work with the data within the database. Does that have a performance penalty because you have to add that extra functionality to the database? And if so, what kind of penalty does that look like?
I'm sorry, do you mean like adding additional feature to the DB2 engine? Does it have a performance penalties for the database engine itself?
Yes.
Okay, so for example, I'm going to use this in DBMS. Okay, so those store procedures, the C store procedures that I mentioned that actually do the feature engineering, the creation of pipelines, cleansing, all this kind of stuff, right? Well, obviously, if we add feature like that, when you're creating your database, those store procedures have to be created. Now, then what happens is, well, okay, so when you start creating new DB, let's say previously you could create it in 2 minutes. Now it's going to be, let's say, 2.5 minutes or 3 minutes or something like that, right? So obviously with every new feature, if it requires additional infrastructure, there might be, as you call it, performance penalties. But those are tasks usually when you're actually configuring and setting up the database. Once the database is created with those features enabled, then all you get is performance benefits.
Interesting to hear.
Right?
And sorry to interrupt, but one thing that I wanted to sort of expand upon what you just said. If there is a performance impact, you mentioned that sometimes it can have a benefit or it can have a penalty, but if there is a performance impact to some features around, for example, machine learning within the database, another part of the question was, can that performance impact be delayed to a time when the database is off peak? So when there aren't as many queries being executed.
Yeah, so enabling something like this, we often use configuration parameters and things like that to enable specific feature. So it's done at whenever the user really wants to, right? So you can flip essentially switches. Let's abstract them to call them switches. There's switches to enable certain features and disable them as needed. It is obviously not expected. The DB2, is infused with so many features that I doubt there is a single customer that uses them all.
Oh,
right.
Yes.
So yeah. So for example, you want OLTP, you deploy DB2 as OLTP, or you have a warehouse, you have a raw warehouse. But if you want to create, columnar tables, you set your analytics workloads, set your workloads on analytics. Like in turn, this will allow you to have both row and column type tables, right?
Yeah.
But again, those are actions that can be done and definitely should be done in off-peak hours, right? But they do not have great effects on the database performance, right? One of the ones that could have, for example, when we actually for a machine learning models, like hosting the ML optimizer, right? So we do need to trigger collection of the statistics to train the model itself. Obviously, you do not want to do this kind of activity during the peak hours when you have all your customers hitting. This is something that obviously should be done in some kind of a weekend time frame when there is barely any kind of access to data levels, right?
Yeah.
But again, those kind of triggering this kind of actions, let's say statistic collection and training the machine learning models. Those are in the power of the DBA, right? And then obviously we can set up some flows automation around it, right? We can set up some kind of alerts and thresholds that will allow me, or even the time windows that will, allow me to automatically trigger this kind of data collections and less machine learning model training or I can still remain fully in control as a DBA and only trigger when I want to.
Interesting. Okay, so I'm going to ask you one more question, and that is, I feel like we may have touched upon this a little bit, but in case you want to sort of add more detail, does DB2 support horizontal scalability?
Okay. That's a very good question. Okay, that's a very good question, and the answer is slightly complex. So when we talk about horizontal, what it's important to highlight is that DB2 have the various modes of deployment. Okay, so we have one node deployments. Okay, and one node deployments usually you would see OLTP, online transaction processing applications. Okay, when you have, let's say, banking application, I'm going to use it as an example, right? Okay, so those are usually running on a single node with row store. They deal with the very point queries that retrieve usually one or few rows of data, right? If I want to see my bank account, this is likely what my bank account balance is, right? This is essentially what I'm kind of using in the backend. From that perspective, we only have vertical scaling for a single node installation, and the vertical scaling in the sense that I can keep throwing CPU and RAM, giving more RAM and CPU to that DB2 instance, basically until I hit the capacity of the server onto which DB2 is running. Okay? We do have ability to do what we call essentially, in this kind of situations, customers often for critical applications set up something called HADR, high disaster recovery, right? So HAM is disaster recovery. Now, in those scenarios, we have a secondary instance of DB2, also one node, running in either the same or a different data center or different availability zone. There is application technologies that actually syncs all the data between those two instances and replays the transactions that occurred in one system onto the other. And those are near sync, or you can basically say, we're talking about the latency that's measured in seconds, okay? Now, what we have as additional capability that could be considered as a horizontal OLTP scaling is basically reads on standby. The standby server, you can still read from that, with exception that your application can accept this, let's say, 5-second latency.
Yeah.
Right, so this is for single nodes. We do have OLTP, something we call DB2 Pure Scale, that allow you to have basic horizontal scaling, because you can have, it is OLTP database, but has been architected to allow you to basically scale out horizontally. But this is not a single node. We're talking about massive systems, let's say 10 power servers, right? Cache facilities, we call them cache facilities, that are actually distributing the workloads. We can scale out additional nodes, the worker nodes in the Pure Scale, they all have access to the same data. So you have a data consistency regarding which member is actually reading this data, right? So this is the OLTP world. So yes, for vertical, for single node, for the multi-node, OLTP, 100% vertical and horizontal. Now for warehousing, this is where we can do both and at ease, right? DB2 can start, you can start with the warehousing database that's spread across, let's say, 4 nodes, okay? And at any point in time, obviously you can increase the capacity on the node itself by increasing CPU and RAM, but you can also add additional nodes, right? I don't want to get into too many technical terms. Our scaling, we have a concept of something we call MLNs. Those are essentially chunk of memory. They've been defined to work with chunk of data. We can reappropriate them. So essentially new node has been added. We spin up another instance of the container of DB2. We basically simply move those MLNs, which are also kind of mini containers in themselves. We put them on these other nodes, boom, voila. We have a horizontally scaled to 5 nodes, right? Yeah. So the answer is yes, but it's the reason it took so much longer for me to explain, because there's nuances depending on what type of database you're actually running.
Yeah, I mean, really, when you have something this complex with like an enterprise and you've got like such complex software like DB2, there's no single answer, I believe, in a lot of these cases. But it is possible. It depends, though, whether or not that makes sense, is how I would sort of summarize what you just said. So that's interesting. Let's see if we have any other questions. All right, so about that question from Parag, we will be getting back to you once more. I already see there are a couple of folks from the DB2 team joining this shake. Thank you for joining the live stream. But we will go ahead and get back to you after the live stream ends. And if you have any more questions, feel free to send that in now as we go through our final sort of things that we want to share with you. Also, Peter, so as you know, we've got a really diverse audience joining today. So, I mean, it's all sorts of people, from developers to people who are just getting into the world of technology to executives and data scientists and everybody in between. And for the audience, is there some sort of closing message that you want to share before we end today's stream?
Oh, well, okay. Diverse closed message to close this kind of discussion. Embrace the challenges, embrace the technology, challenge the status quo, right? Expect, have certain level of expectation. Don't settle for, basically incomplete solutions. Right? Have faith that we can actually, that there is actually offerings out there that will allow you to succeed in what you do. It's really hard to say. Maybe not as an inspirational message I was intending, how it sounded in my end, but don't settle for anything that's, don't settle for second best.
That
right?
makes a lot of sense. Don't settle for second best. That is still that is a great message to see, especially when we're talking about this technology like databases and how we're taking something that developers traditionally see as something from the past, something that's not exciting. I mean, you literally mentioned it in your slides. It is that or data scientists and things like this. Of course, they can be trained to deal with different kinds of data and whatever. But do they really enjoy it? Is it what they want to do? And when other organizations offer other solutions that enable them to abstract that away, obviously developers are going to want to use that solution. So it's a great thing that DB2 is providing that solution. It's great that DB2 has this sort of capability to integrate next generation technologies directly into the database. I mean, what you mentioned with the 3 pillars really also highlights how machine learning technology is so generic that it can be applied essentially anywhere within any field, right? So I mean, it's even impacting itself, right? We're using machine learning technology to develop machine learning algorithms, auto AI in the Watson Studio.
Yeah, that's true.
And so machine learning is applicable quite literally anywhere. And so the fact that machine learning technology is being used in the back end of the database within the DB2 engine, while at the same time the DB2 engine is providing developers with the infrastructure to integrate machine learning with the data within the database directly, enabling security and performance, while at the same time also providing more features within the database, making it more convenient for data scientists and machine learning engineers to integrate that technology into their apps. That is quite incredible. And so once again, thank you very much, Piotr, for joining today's show. It was an honor to have you on.
Okay.
Thank you very much.
I'm surprised. This was supposed to be 45 minutes. What happened?
Well, we had a really good conversation. We had a lot of questions, and I was glad to be able to hear all your thoughts. Thank you very much.
All right, thank you, then. This was great. I appreciate it.
Of course. Thank you for being on the show.
Thank you for sticking around so long. Yeah.
Yeah, thanks for everybody for joining in. I do see there are a couple of questions about like how can we get into the world of programming, machine learning as beginners. We're gonna have a very special episode next week. Actually, about one of the topics will be about that, and so stay tuned because next week's episode is going to be really fascinating. I'll give you a hint. One of the topics is going to be IoT. So. Stay tuned for that. All right, and with that, thank you very much once again, Piotr. Great to have you on the show. Thank you very much, everyone, for joining in today, and goodbye, everybody.